Okay, this question concerns calculus, differentiation and connected rates of change, but in particular this question concerns small increments, an increase by 1%, that's a small increment, and this gives us a particular way to solve. What I want you to imagine is, I want you to imagine a graph. There's a graph. And this is the radius against the area of this oil dripping from a pipe. So what I've got, oil dripping from a pipe into a big old puddle, and it's got a certain radius, and we know the area is pi times radius squared. And if we were to look at a graph of the increase of that, we would see this. Area equals pi r squared. And the gradient of this graph, dA dr, equals, differentiate this, 2 pi r. Now, what I will do is I'm going to home in on a small section of this graph, and I'm going to look at a small increment in the radius, and I'm going to ask myself what the relative increment is in the area. So, the way to do this, the closer I look, then this graph, although curved at small points, will start to look straight. The closer I get, the straighter it looks. So once I start to imagine it's a straight line, all I need is a triangle to figure out this increment in the height if I know the increment in this. So I've got my dr, my small increment in radius, and I want my dA. This formula for small increments, what I can say is that my small increment in dA will be equal to the gradient dA dr, which I'm imagining now is straight, times by dr. So my dA will be 2 pi r, gradient, times dr. dr, I'm told, increases by 1%, so it will be 0.01 of the radius, and so dA will be 2 pi r times 0.01 of r. In other words, 0.02 pi r squared. And finally then, for our percentage increase, well, the small increment 0.02 pi r squared over the actual area, which is pi r squared, times by 100 to give me a percentage, pi r squared, and I reckon that is 2% increase in area.